All right, this is Precalculus, chapter 13, exercises for lesson 4 on page 882. All right, here are the problems. Y'all know we always only do the odd, right? Okay, so in number 1, it says they're drawing a marble out of a bag, observing the color, placing it back in the bag. That's a key word, right? And it's going to be repeated 75 times with the following results. Okay? So it wants us to write a probability distribution. So your probability distribution looks like the possible outcome, which is the color of the marble, right? And then the probability below it. All right, so there's 70, how many marbles total?
75.
Are there 75 marbles? The experiment is repeated 75 times.
There's also 75.
And there's also 75 marbles. Thank you. So the outcomes are red, blue, green, and yellow. What's the probability of getting a red?
38 out of 75.
38/75. Blue.
23.
Thank you. They write these as decimals. Either way works. Green.
11/75.
And then yellow. 3/75. And they should actually be simplified. Like I say that because I just know 3/75 is 1/25. You should always simplify. Yes. I'm going to write it in decimal form because I might need it. In a minute. Okay. So that's number 1. A probability distribution, right? You just list the outcomes, you list the probabilities. All right? Language is what matters. Do you understand the language? Can you write a probability distribution? It's the outcome and the probability. All right, number 3. Based on your distribution, what is the probability of drawing 2 yellow marbles in a row? Yes.
So this would be multiplication.
I have 2 experiments. Yes. All right, so what's the probability of drawing 1?
1/25 or 1/25.
So it'll be 1/25 times 1/25. I think 25 times 25 is 625. Is that true? I'm sure they give it to me as a decimal, but I don't even see it. Oh, I do see it. They give it to me as a decimal as 0.0016. Does that make sense? Everybody good with that? All right, number 5. A dreidel is a top with 4 sides used in a game by Hebrew kids, and those are the sides. It is spun 100 times with the following results. Okay, y'all can write the probability distribution for the dreidel, right? So this is number 5. So the outcome would be, that's really just that. What's the total? 100 times.
100.
Thank you. So that's 1/10 or 0.1. That's 45 hundredths or 0.45. These are easy to write as decimals, right? Those were easy to write as decimals. When they're all over 100, you just put the decimal in front. You don't have to write both of them. It's nice to have both of them. Because I bet my answer key has just the decimals. I'm sure. Okay, does everybody understand probability distribution? The favorable outcome over the total possible outcomes. That's all it is. Everybody good with this?
Yeah.
All right, number 7. Number 7 says a player loses tokens if the dreidel lands on none. What is the probability of losing 4 times in a row?
We'll just subtract. Wait, what?
Or 0.1 raised to the 4th power. Right? What is that?
1/10,000.
How many zeros after the decimal?
4.
You sure?
No.
I think it's only 3.
I think I guessed. 4. Well, it's 1
Yes.
over 10 times 1 over 10 times 1 over 10 times 1 over 10.
That's why I did 4.
So that would be 4 tens. So it's 1 divided by 10 to the 4. So that would be like.
Why didn't we just use our calculators, people?
How do you get it? If I did 3, we might do.
This is correct.
0, tens, hundreds, thousands, and thousands. Okay, I thought there was that wrong, but I don't know why.
But it is 1/1000.
No, it's not.
1
It's 1
10,000.
That's
And it's-
Just put it in your calculator, right? No reason not to.
What mode we put it in that? I don't know, mine's. I
Okay.
put 1 each negative.
That's what I have also.
Oh,
I forgot how to
okay.
change it back. Sorry.
Okay, mode. Go mode. Go down to answer. You have it in decimal. Go to auto. Let's see if auto works.
Auto does not work.
Auto doesn't work. Okay, well, you know when it's -4, it's 1. Okay, look, this is what you have in your calculator. It's 1 e to the -4. You got it? Right? That's what's in your calculator.
Move the decimal.
Okay, everybody watch. The decimal's here. Move the decimal left 4. 1, 2, 3, 4. Got it? Move the decimal left 4. That's all that means.
3 zeros. 4 if it's a fraction. Because remember, decimal starts tens, hundreds, thousands.
Or when you multiply it this way, everybody look, when you multiply it this way, you know it's going to be 1, but how many decimals do we have? 1, 2, 3, 4. All right, you got it? Okay. Number 9 says run a simulation. Are we running any simulations?
We are not.
We're not, so we're not doing number 9.
13.
Can we do number 11 if we don't do number 9?
No.
We cannot.
That's awful.
So we're not doing numbers 9 or 11. I need to change that. Okay. So let's start on number 15. And if I were you, I would go work some of the even ones here. It will help you on your test. Okay? You want me to give you the answers to the even problems really quick?
Okay, which even ones?
Okay. The even ones here. I'm going to give you the answers real quickly to the even ones. Okay, number 14 is 0.04. Number 16, 0.36. Number 18, 30. Number 20, 17 million. 576,000. So it's 17, comma, 576, comma, 000. Number 22, 336. Number 24, big number, all right? 56, comma, 921, comma, 900. 56,921,900,000. Okay, that's the ones I would go work. Now let's go back to 15. Oh, we got to read it. A teacher writes the name of each of her 25 students on a sheet of paper, place them in a box. She's going to call on the student. She's going to draw a slip of paper. All right. So what is the probability of calling on the same student twice in a row? So here's the first time I call on them. Here's the second time I call on them. Got it? What's the probability that I call on this student the first time? 1 out of 25. Are these mutually exclusive or independent events?
Independent.
They're independent, so I'm multiplying. Calling on that same student the second time is 1/25. Didn't we just get this answer somewhere else?
Yes.
We did, huh? That's the probability. Or 0.0016. That's what the textbook has. All right, so is everybody good with that? All right, if the class contains 11 boys and 14 girls, that's still 25 students. What is the probability of calling on a girl? 17. What's the probability of calling on a girl?
14 out of 25.
Got it? 14 out of 25. Favorable, the number of girls over total possible outcomes, 25 students. 14 out of 25.
So when, like, in the box on the other page when it says that the probability is equal to the number of outcomes over.
The number of favorable outcomes over total.
It's confusing.
I wrote it as favorable.
I know you did, but the box
That it didn't.
It just looks different.
Yeah. Number of outcomes in the event. That's favorable outcomes. So just write favorable. Over N, which is the total, is like your whole sample space. N is always your whole sample space. It does word it differently. Hannah, you're right. All right, so does everybody have that? The probability that an event occurs is the favorable outcomes over the total possible outcomes. Okay, so 14 over 25 is girls. What is the probability of calling on a girl, of calling on 3 girls in a row? All right, what do you think?
Wait, is it addition? Like,
How many events are there?
3.
no.
You always think independent when there's more than one event.
Okay, so you do multiply.
We are multiplying.
How do you know if it's the same event?
How do we know if it's the same girl? You don't, but it said that the papers are replaced in the box. So that's in that dark reading above number 14.
Well, I mean, like,
Hold them
how do you know it's
simultaneously.
the same event and it's not like she's doing it 3 times in a row, so she's doing it at a different time. So that's what makes.
Because of the description of the event. Look at what it says. She draws a slip of paper. The student is called. She puts it back. It's not like she's drawn 3 slips of paper at one time.
So they're independent.
It's the description. Yes. So it's 14 25ths times 14 25ths times 14 25ths. Okay, what do y'all get when you multiply that? Or it's 14 25ths cubed. 0.1756. There we go. That's number 17. Okay. So that is the end of those questions related to the boys and the girls. All right. So now we move to number, did I say? Yeah, we did 17. 19. All right, a quiz has 5 true, false. I like to write this down. 5 true, false. You only have 2 solutions, right? And 3 multiple choice. 3 multiple choice with how many options? 4. So A, B, C, D. A, B, C, D, right? All right. You got that so far? How many possible ways are there to answer the 8 questions? Well, I have 2 options here.
2 times 12.
And I have 5 questions. So it's 2 times 2 times 2 times 2 times 2. Right? It's 2 times 2 times, 2 times 2 times 2 times 2 times 2. That's how many, this is the fundamental counting principle. We're not asking the probability of a particular outcome. Do you see that? They're not asking for the probability of a specific outcome. They're saying, what are the total possible outcomes?
They want the denominator.
They want the denominator. That is exactly right. Okay. But now we have 4 options and 3 questions. So what is that going to be? 4 cubed. What is 2 to the 5th times 4 cubed? You do multiply. Why? How many events are there? There are 8 separate events, right? Because 8 questions. It's not like I'm going to answer 2 questions at one time. I could try, but I'm not. All right, so what does that equal?
2048.
That is correct.
A very large number.
It is isn't that crazy?
It's like ACT.
5 options,
On the map.
60 questions.
Why would they do that to you?
5 to the 60th are the different combinations that you could have on the ACT.
Oh my goodness. I think it's more of
And that's 5 to the 60th. There are 5 options for each question and 60 questions. That's just math. Just math. Okay. All right. That was number 19. 21. Okay, I want y'all to think with me about this. A gallery has 25 paintings in its permanent collection with display space for 10 at one time. Okay, let me ask you. Does order matter?
No.
I don't think order matters.
I don't know.
So what is this? It's a combination because order doesn't matter. So we have, how many paintings? We have 25 paintings. We're choosing 10. So you can either do 25, C 10, or you can do, here we have 10 spots. This is what I always do on the ACT.
Are you gonna make us do it without
Got a calculator?
No. You do 25 times 24 times 23, so far down. All right, so what do you get? This is a big number.
I got
32.
3 million.
Keep giving me numbers.
3268760.
Yeah, that's it. Got it? Did everybody get this number?
Yes, ma'am.
Okay.
Which number is this one?
All right, that's how many different arrangements of collections that can be shown. Okay. 23. Oh man, I sort of gave this one away earlier in class. A baseball team has 9 players. How many different batting orders are there? All right, so do you think order matters?
Yes.
I think order matters. Y'all, NCR and NPR are on this calculator too.
But in this case, this is just combinations though, right? Because there's all the batting orders. So you're arranging.
Well, it's 9 and we're choosing 9.
Oh, so you do 9.
It's really 9
Exclamation mark.
factorial.
Exclamation.
Correct. It's really 9 factorial.
Where is my
Or it's 9 P9. Or it's 9 factorial. To me, it's just easy to know it's 9 factorial. Both of those would get you the same. Factorial is on this calculator as well.
It's under math and the one far right.
Yes, and on this calculator, it's shift x to the -1. All right, so did y'all get that? What's the answer? 362,880. Everybody got 362,880? Okay. Now we move to problem 27. Okay. Wait, we got to go back and read. All right, you got to read the bottom of the previous page. A botanist is testing 2 kinds of seeds. She divides a plot into 16 equal areas from 1 to 16. She then randomly chooses 8 of the areas to plant seed A and the other 8 to plant seed B. Okay, so thus you have the drawing on the top of page 884. 16 16 plots, right? How many ways are there to choose 8 plots out of 16? So, does order matter?
Yes.
You think order matters?
Well, but you want different ones, right?
Listen what she said. She then randomly chooses 8 of these areas to plant seed A and the remaining B. Does order matter? Does it sound like order matters? It doesn't sound like order matters. Now, if you're planting blueberry trees, you better be planting those babies next to each other or they will not produce good fruit. But based on the wording, it didn't sound like order mattered. So we have 16 plots. We're going to choose 8. And order doesn't matter. What do you get? Say it. 12,870. Okay, now you realize you could have used those formulas, right? This is not too hard, but the formulas are on page 881. However, ladies and gentlemen, everybody look, if you take a college class and have to know this, I can't imagine any of you will, unless you go into nursing. So maybe one of you will. Look, it's on this calculator. NPR and NCR are on this old calculator because you can't use that other calculator.